All right, got a networking exam coming up? Don't stress. We're going to break down some of the trickiest concepts from weeks 9 and 10 to get you totally ready. Okay, so here's the plan. First up, we've got ARP. That's all about how devices find each other. Then, we'll get into the data link layer. Think of it as the rules of the road for data. After that, we'll touch on SNMP, which is like the network's watchdog. And of course, we'll wrap it all up with a super quick recap to make sure you're good to go for that exam.
You ever click play on a video and wonder what actually happens in that first split second? I mean, it feels instant, doesn't it? But believe it or not, before a single pixel appears, your computer has to have this super quick, super important chat with your router. And that little chat, well, that's where we're going to start.
All right, let's kick things off with our first big topic, ARP. Now, that stands for Address Resolution Protocol, and honestly, it's one of the most fundamental things that has to happen for any data to get anywhere. So here's the puzzle, right? Your laptop knows the router's IP address, but that's just a number. How does it know where to physically send the data? I mean, which specific piece of hardware is it? This is the exact problem ARP solves. Think of it this way. Knowing an IP address is like knowing my name. Cool. But if you want to send me a letter, you need my actual street address. It's the same deal here. And to really get this, we need to be crystal clear on the two kinds of addresses every device has. First, you've got the IP address. Think of this as the who. It's a logical address, and it can change. Like if you take your laptop from home to a coffee shop, you get a new IP address. Then you have the MAC address. This is the where. It's a physical address that's burned right into the network card when it's made. It never, ever changes. It's like the device's fingerprint. And this is where ARP comes in to save the day. It's basically the network's directory assistance. Its one and only job is to translate that who, the IP address, into the where, the physical MAC address. It's the bridge between a logical name and a physical location. Okay, so how does it actually work? It's surprisingly simple, almost like a town crier. First, your laptop sends out what's called an ARP request. This is a broadcast, which means it literally shouts out to everyone on the network, hey, who has this IP address? I need your MAC address. Then all the other devices hear it, but ignore it, except for the one device that actually has that IP, the router in our case. The router then replies directly back to the laptop, and only the laptop. That's a unicast. It says, yep, that's me, here's my MAC address. And boom, problem solved. Now for your exam, listen up. This is a super common question. If you remember one thing about ARP, remember this. Its job is to map IP addresses to MAC addresses. It connects the logical network layer to the physical data link layer. Just burn that into your brain. ARP equals IP to MAC. Okay, so our devices can find each other now. Awesome. But how do they make sure their conversation is smooth and error-free? Well, that's where the data link layer comes in. Think of it as setting the rules of the road for communication. So the data link layer does a few things, like breaking data into chunks called frames. But for our purposes, and definitely for your exam, we're going to focus on two absolutely crucial jobs it has: flow control and error control, basically managing the speed and making sure the data is accurate. This quote here really hits the nail on the head. Flow control is all about telling the sender how much it can send before it has to, take a break. Imagine you have a super fast new computer sending a huge file to an older, slower one. The new computer can just fire hose data, but the old one can't keep up. Without flow control, that extra data just gets lost. Poof, gone. And this analogy is perfect. It's like you're telling a story to a friend, but you're talking a mile a minute. Your friend is going to have to say, whoa, slow down a sec, let me catch up. That's exactly what flow control does. The receiving device is telling the sending device to ease up on the gas so its memory doesn't get flooded. Okay, so we've managed the speed, but what if the data that arrives is just wrong? What if some electrical noise messes it up or a chunk of it just vanishes into thin air? That's a whole other problem, and that's what error control is designed to fix. The phone number analogy is great for this. When someone tells you a number, you usually repeat it back to make sure you got it right. Error control is kind of like that, but with math. The sender runs a little calculation on the data, like a checksum. You might see terms like CRC or LRC, and attaches the answer. The receiver gets the data, runs the exact same calculation, and compares its answer to the one that was sent. If they don't match, it knows the data is bad, throws it out, and asks for it to be sent again. Simple as that. So another big exam tip here, when you see data link layer, I want you to immediately think of two things: flow control, managing speed, and error control, ensuring accuracy. These two are the foundation of reliable communication between two devices. All right, so we've gone from the micro level, how two devices talk. Now let's zoom way out to the macro level. How do we manage an entire network with hundreds or even thousands of devices? I mean, seriously, think about a big university campus or a huge office building. How does the network administrator know if everything's working? They can't just walk from server room to server room checking on blinking lights. That's impossible. They need an automated system, something that acts like their eyes and ears across the whole network. And that system, you guessed it, is SNMP. It stands for Simple Network Management Protocol. And the keyword there really is simple. It was designed from the ground up to be a really straightforward way for one central computer to monitor and manage everything else on the network. Honestly, the best way to think about SNMP is to picture the dashboard in your car. It does three main things. First, it lets you monitor the health of things, just like you check your fuel gauge or engine temperature. Second, it gives you alerts when something's wrong. That's your check engine light. In SNMP, these are called traps. And third, sometimes it lets you change settings, kind of like turning on the AC from the driver's seat. Okay, for the exam, don't overthink this one. You don't need to know all the nuts and bolts. Just remember, SNMP is for monitoring and managing the network. That's it. It's the network's health dashboard. All right, we have covered a ton of ground, from how one laptop finds a router all the way up to managing a giant network. So let's do a super quick recap just to make sure all these ideas are locked in place before your exam. Okay, look at this table as your ultimate study guide. We've got our three big topics, their core job, and that simple analogy to help you remember. ARP, that's your address book, finding a desk number from a name. The data link layer, that's just good conversation rules. Don't talk too fast and make sure you heard correctly. And SNMP, that's the car dashboard, giving you a quick look at the whole system's health. Easy. Look, if you're cramming for the exam and you're short on time, focus on these four things right here. Know what ARP does, IP to MAC, understand the difference between a temporary IP and a permanent MAC, be able to explain flow and error control for the data link layer, and finally, know the one-sentence purpose of SNMP. If you nail these 4 points, you're going to be in really good shape. All right, last thing. Let's see what you've learned. Here are a few potential exam questions. I want you to actually pause this and try to answer them out loud. If you can explain these concepts clearly without stumbling, then you are absolutely ready for this exam. Seriously, great job for sticking with it and good luck.